Okay, so for rational functions, we have a method cut out, but it turns out that you can't always be working with rational functions. So we need a better rule, and there is a rule called the L'Hopital's rule, which provides an easy way to evaluate indeterminates of this form. Here's what the rule says: if you have two functions f and g, which are differentiable, and g prime, or the derivative of g at x, is not zero on some open interval I that contains a, except possibly at a. And then let the limit as x goes to a of f of x be 0, and the limit of g of x as x goes to a also be 0, or let these limits be infinities. Then the ratio, or the limit of the ratio, becomes the limit of the ratio of the derivatives, yeah, if the limit on the right side exists. Now note here, warning, this is not the quotient rule, right? You're not taking the derivative of the entire fraction. It's actually way easier. You're taking the derivative of the numerator separately and then the denominator separately. Example, x goes to 0 sine x over x. The first step is to check, yes, it is indeterminate, so I can apply the rule. Take the derivative, cosine x over 1 becomes cosine 0, which is 1. Similarly, log x over negative 1 plus x, take the derivatives and it comes out to be 1. This first step is essential. You have to check that it is an indeterminate form. Uh, Another example, e to the x over x squared. You take the derivative, you end up with e to the x over 2x, and this is still infinity over infinity. So I can apply the rule again. So what this shows us is that you may have to apply the rule more than once. When you apply it the second time, you end up with e to the x over 2, which becomes infinity. More examples. Recall in the last example, we saw that e to the x over x squared equals infinity by applying L'Hopital rule twice. Um, Use that method to answer the following, these two, a and b, and then verify that both of them should come out to be positive infinity. Here's another problem, log x over cube root of x. So again, essential step, you can use the rule, take the derivative, and you end up with 1 over x and 1/3 x to the negative 2/3, which is now 0 over 0. So it's still indeterminate, but because these are all x terms, let's try to simplify them first. It's 1 over x divided by 1 over 3x to the negative 2/3, which becomes 1 over x divided by 1 over 3x to the 2/3, because that's a negative exponent. Changing the division into multiplication flips this fraction, so you get 3x to the 2/3, and then x to the 2/3 minus 1 gives me a 1/3 in the denominator. So this is actually 0. I don't have to apply the rule again. Now again, warning, very, very important. This rule only works for the indeterminate forms, namely 0 over 0 or infinity over infinity. If you use it for any other form, you're going to get garbage answer. Okay, next we're going to look at other forms which can be converted to indeterminate forms.